NASA's James Webb Space Telescope, launched on December 25, 2021, aims to study the oldest stars and delve deeper into the universe's history than ever before. Known as Webb or JWST, this telescope is considered a partial successor to the Hubble Space Telescope. However, compared to Hubble, JWST stands out as the largest and most powerful space telescope ever built. Launched from French Guiana on an Ariane 5 rocket, it is poised to be the leading observatory for the next decade. Webb was designed under NASA's leadership with contributions from 15 different countries, as well as the European and Canadian space agencies. After 30 years in the making, the telescope will examine everything from the first bright lights after the Big Bang to the formation of solar systems. JWST possesses advanced technology capable of observing the formation of the universe's first stars and galaxies 13.5 billion years ago. This is crucial for providing deep insights into the early universe. Webb's primary focus is on near-infrared astronomy due to the universe's continuous expansion and the redshift of ultraviolet and visible light emitted by the earliest luminous objects. Hence, the visible emissions from red-shifted objects can be shifted to infrared, and cold objects like debris disks and planets emit infrared radiation, which is impossible to observe from Earth or closer space telescopes. However, Webb, utilizing artificial neural networks, can monitor, record, and directly relay these changes to observers. Webb's observational power lies in its ability to track infrared radiation with high sensitivity and unprecedented resolution. The telescope will be a powerful tool for studying nearby universes and a significant resource for determining the origins and evolution of stars. Webb can compare exoplanets around other stars with our own stars, shedding light on the development within the Milky Way galaxy. Additionally, it is capable of observing the habitable zones of stars and the potential presence of liquid water on planets. Using the technique of transmission spectroscopy, Webb can investigate the chemical compositions of planetary atmospheres by analyzing light filtered through them. One of the most remarkable features of James Webb is its ability to explore the universe's past to unprecedented depths. Webb can look much further back in time than Hubble, up to 13.5 billion years. This period covers 100 to 250 million years after the Big Bang, a time frame never before examined. Webb will investigate how galaxies form and evolve, capture images of planets in our solar system, and search for evidence of dark matter. The most exciting aspect is its potential to find habitable planets by probing exoplanet atmospheres for chemical signatures of life or measuring oxygen levels. Webb can also peer into the dust clouds where stars and planetary systems are born, a capability beyond Hubble's visible light observation instruments. The telescope is equipped with mirrors made of ultra-light beryllium, divided into 18 segments that unfold and align once in space. Its 5-layer sun shield, the size of a tennis court, reduces heat from the sun by over 1 million times, keeping Webb cool. Its cameras and spectrometers can record even the faintest signals. After its launch, Webb traveled to an orbit about 1 million miles from Earth, where it began operations. While it can't directly see dark matter, which makes up a large part of galaxy masses and clusters, it can measure its effects using gravitational lensing. According to Einstein's general theory of relativity, light beams will bend as they pass by massive objects. These distortions can be seen by the telescope, allowing Webb to provide astronomers with comparative images of other galaxies. The data gathered will help clarify the nature of dark matter in the galaxy. James Webb's primary mirror is about 6.5 meters tall, composed of 18 separate segments. Webb's sun shield is one of its most critical features, designed with a complex structure essential for the mission's success. Made of Captain, this 5-layer sun shield covers an area approximately the size of a tennis court, 22 meters by 12 meters. It can reduce heat from the sun by a factor of at least 1 million, ensuring that Webb remains cool and protected from infrared radiation from the Sun, Moon, and Earth. This cooling is vital for Webb to perform its functions. The James Webb Space Telescope is nearly twice the size of the Hubble, at 13 meters tall, but weighs only half as much at 6,500 kilograms. Webb is so large that it couldn't be launched fully open. Engineers solved this by folding the telescope like origami, and it unfolded once it reached its observation point. The unfolding process is more akin to a blooming flower than origami. A particularly exciting detail about Webb's launch is its location at the second Lagrange point, L2, 1.5 million kilometers from Earth. This distance is almost 4 times the distance to the Moon. Unlike Hubble, which orbits Earth and can be easily serviced by astronauts, Webb won't have that luxury. So where James Webb was NASA's top official. The 1950s and 1960s in America saw heightened persecution of homosexuals. While there is no clear evidence implicating Webb in these discriminatory actions, it is known that he did not actively oppose them during his leadership. NASA, although reluctant to be embroiled in such discussions, has stated that an investigation was conducted and found no evidence supporting claims of Webb's discrimination against homosexuals. However, NASA's explanation has failed to convince many scientists, who also criticize the agency for not releasing a report detailing the investigation's scope, citing concerns about transparency. Astronomer Johanna Teske from the Carnegie Institution for Science in Washington, D.C., expressed disappointment, stating, "I am disappointed. Without knowing which factors were considered, it is difficult to respect the decision to retain the current name. Respect cannot be enforced." Meanwhile, NASA's acting chief historian Brian Odom confirmed in a September 30, 2021 interview with Nature that the investigation had concluded. He emphasized that greater care would be taken in naming significant developments in the future,